Wow, did I give you the same one twice? Seems silly. Let's skip that one and do... Oh, you know which one we should do. We'll skip this one because obviously we're not going to do the same one twice. Why don't you guys do 3?
She said she was fine doing a company. Well, I have a burrito in my stomach when swimming. Not that I swim anything hard.
So you guys are going to do example 3.
Yeah.
See how you're doing with this. And in fact, if you can do example 3, I'll call it a day. I mean, it's not that I don't believe in you.
Is that what it is?
No, I do believe in you. It's just the first time you try something in a long time, sometimes you're prone to make small mistakes that you don't mean to make.
So true.
I should probably do it.
I don't like ask my question. It's like, in case someone takes something. With this or with this being good and this being awesome.
Other way around here.
Okay, because I never remember. And then like polysmalls was different than.
Well, so these 2 things need to add to this, right?
Yeah.
So the bigger of the 2 numbers always is that sign.
Okay. I'm not sure. It's like when the X were. Yeah. You must have multiplied something wrong.
Nope.
I might be double checking A and B. Once you're done, go ahead and check your answer against mine. No.
It's so fun.
Doesn't it though?
It does.
Hey guys, if I asked you to factor this denominator, could we do so?
Yes. Because it was the same as the one. No. You missed your guys' chattering like we're in a.
Yeah, it was a lot quieter.
Sure. Oh,
You did that quick. You did that. We gotta keep it lively, you know.
Yeah.
When you're crying inside, you can't be crying outside.
Oh boy.
Or when you
We
are
can do
crying
both.
Or, I
outside,
mean,
you
you
need
can
a
do
little
both.
pizzazz.
We do both, but. That wasn't fun.
Okay. Are you guys with me so far?
Yeah.
So in this situation we have, 3 factors in the denominator, yes? Which presents us with that we have something over the first factor plus something over the second factor plus something over the third factor. Okay, so what do I need to multiply the first fraction by?
X minus 2 and X plus 1.
And then this one will be x x plus 1, then x minus 2. So as I look at this, I'm now getting ax squared minus ax minus 2a, and then plus bx squared plus bx plus cx squared minus 2cx. And that has to equal 3x squared plus 7x minus 2. Yes.
When we first factored, could we have just factored it as x and x squared minus x minus 2, and then just done it with like 2 sections? No. Why not?
Essentially, you have to break it down as far as you can. Because what happens is you could have multiple fractions. The fact that it's possible you could have had these two fractions means you have to do it. So you have to account for every single possible fraction that you could have. Yes. How we feeling?
I had C as -3.
That's what I got too.
-2.
Did you get A equals 1?
Yeah.
And then did you get B equals 8 plus 2C?
Yeah.
And then you plug that in?
Yeah.
Oh, hold on. So that should be there. I missed a plus C. Okay. So you have 8 plus 3C equals 2. So C equals 2, negative 2.
Okay, that's what I got. Which would,
That makes sense.
is it 8? Yeah. Okay, that's what I got.
C was -6. Do we have to write that interval with like the letters over the, or not the letters, but like the 1 over x plus, or can we just?
I feel like that is an important intermediate step. Essentially, it communicates, you know, what goes above what. So we should have ln of x plus 4 ln of x minus 2 minus 2 ln of x plus 1. Feeling good?
Plus C.
It's hilarious that you say that because several of you are going to be really annoyed when you see your quiz grades.
We forget plus C.
There were several people who forgot plus C. And you can't see them yet.
I'm taking it tomorrow.
You'll have them back tomorrow. You won't. I don't think. Unless we get through the improper integrals more quickly than I thought we would. All right, how are we feeling so far?
So if we see x cubed, would you recommend that we pull out an x and then factor it from there?
Yeah, if you can.
Yeah.
Is it possible I give you one where you can't do that? Absolutely. And then you put it in polysmelt.
Where's the C?
You can move on. This is just.
I would like to skip example 5 for now and jump down to example 6. There's something in my work I don't like and would like to... Oh my God. There are many things in my work that I dislike and would like to rework it before I show it to you. Nope, I thought I'd give you the whole test during the late start.
When is
Oh,
this?
Monday's a late start.
Tuesday, or there's a late start on Monday, so theoretically your test should be on Monday. Obviously, it's not going to be. So on Monday, we're essentially, we have one more topic after this one to learn, and then it's get ready for the test. I think, and you guys have a quiz on Thursday. Yeah.
This Thursday?
Mm-hmm. You don't have to take it. I mean, you just take a 0.
Okay, well.
Right. You guys, how is this one different?
You probably have to do it twice.
So we still have to factor.
Oh, yeah, go ahead and try and factor x squared minus 2x
Like
plus
that
3.
extra.
Which one? Wait, which one?
My guess is it's on
Yeah,
factor.
it
It's
is.
the same as
Do we distribute and then factor?
Factoring is undistributing, yes? Doing factoring is undistributed. So if you distribute and then undistribute, then you would factor again, like it would factor back out to this. Cool? All right. So what happens is we're still gonna like break it up as in we have one fraction that's over x minus 2, and we have another fraction that's over x squared minus 2x plus 3.
sorry, that's what I did on the homework, and then you said we couldn't do that, so I just erased it all.
That being said, the numerator of this fraction is not a constant.
Okay, so, like,
It doesn't have to be a constant. It could be any linear term. So we're going to put this as bx plus c over x squared minus 2x plus 3.
And why is it a linear term and not just like why couldn't it be a constant?
It could be a constant. And if we solve this and we get b equals 0, it is a constant.
Okay.
So the idea is we don't know for sure that it's a constant, so we figure it out as if, you know. All right, so then we get what? Ax squared minus 2ax plus 3a plus bx squared plus cx minus 2bx minus 2c equals 7x squared minus 13x plus 13. Oh man, you guys aren't going to like this example. What a good opportunity to practice so many different integration techniques that we're going to end up doing. Well, you'll see.
I'm sure
A plus B equals 7.
you.
And let's see, that would be negative 2a minus 2b equals negative 13. And 3a minus 2c equals 13. I feel like I'm missing something.
Yeah,
C,
C.
you're missing the C, aren't you?
And
For the-
plus C
In the
and
middle, I
negative
think.
13.
Okay, I just put a c out front.
oh,
Is that okay? Right? Yeah. How did I decide to do this?
Yeah, well, it's just the best way to.
put everything in terms of A.
Okay. So let's see, that would mean B equals 7 minus A. And C would equal 13 minus 3A over negative 2.
Oh, okay,
I'm not
I'm
putting
looking at,
things
I'm
in
looking, I'm
terms
looking at the wrong one.
And then so we would have 13A minus 3A over negative 2 minus 2A minus 2 times 7 minus A equals negative 13. This is not how I did this, so this will be really fun.
One in A, let's see. Okay, so you're
Yeah,
just
A
didn't
equals
organize,
five.
yes, yes.
And then
that-
how did you put that in?
I plugged everything into this, because then I put this in terms of A.
Okay.
I mean, when I worked it differently,
How would you take the
Doesn't
integral?
C equals 1.
Yes. But do you have long division? Why do you have
Wait,
separate?
how did you get two things for A equals 2?
Oh.
You solve C equals 1. So then it's you want
Oh,
A
you
to
just
just like
separate it.
a variable in it.
Let's just do this in X squared.
Yeah, why not in A and just use it?
But not for the one, not for the one over. Because you said would be 2x minus 2. Actually, yeah, the minus 2 messes things up.
Yeah, the
Just
minus
go-
2 is.
I keep not getting A equals 5. I got it
A
here.
equals 5?
I got A equals 5 when I worked it on my own,
Oh.
but I'm struggling to find. Maybe I'm gonna.
How'd you get like 26?
Once I plugged this in, I multiplied everything by -2 to get rid of the fraction.
The fraction was pretty easy, actually.
Oh, wait, yeah.
Yeah, I just kept fast track.
What about,
Did you guys do long division to solve that rule?
I think
we are still,
possible,
we
but I
are
haven't
not
done.
there yet.
Why heard you guys say long division?
Okay, now I'm good. Okay. So did you guys end up with what we're integrating is the integral of 5 over x minus 2 dx plus the integral of 2x plus 1 over x squared minus 2x plus 3 dx. Are we all there? All right.
The first one's easy, the second one you have to do long division.
Possibly.
You don't have to do long division. Long division is only helpful if at least the degree of the top and the degree of the bottom are the same or the degree of the top is bigger. Long division for this one would be 0 plus 2x plus 1 over x squared minus 2x plus 3.
Oh, wait.
Mm,
I'm done.
wait, I
U
have
sub would
a-
be super easy for this. We just don't separate it.
Oh, that is true.
Mm.
No, it isn't,
it's
because you
not.
have that plus 1 you
Because
can't separate.
use.
I think, couldn't
Oh,
you
wait,
do,
because
have it as
minus
1
2,
over,
not plus 2. If it was plus 2, we could do it.
if you just make x squared,
Do we need to use the like the B and the DB and the
I would not.
Okay.
Though the step to do this one, I don't think you guys are gonna like.
is it like, you know how when we had the ex over something where it's like ex minus 1 plus 1? Could you do that?
We're gonna end up doing something like that.
Because-
Okay, so are you guys with me? What's the problem with using? First of all, are we all good in integrating the first fraction?
Yes.
It's the second one that's a little bit hairy.
Mm-hmm.
Okay, and why can't we use u sub here?
Because if you use the bottom as your u sub, then you'll get x minus, or 2x minus 2, which you can't then separate to get your top, like your different place.
So so you're saying we have 2x minus 2 dx. Yeah? Man. So what do we do?
I think the bottom, what you should do is you have it as x squared minus, or you could do plus x minus 3x, and then you could have u on the bottom.
If I change my denominator, like that's not going to work, because what happens is then when you take that derivative, it's still going to work out to be 2x minus 2.
Oh, so on the top,
we
you
like-
just do minus 2 plus 2.
We won't do minus 2. We're going to do minus 3 plus 3. Why would I want to do minus 3 plus 3?
So you have this thing one.
2x minus 1, or 2x plus 1 minus 3 is 2x minus 2. And then I'm going to add to it the fraction, because as soon as 3 over x squared minus 2x plus 3. What are your thoughts on how we integrate 3 over x squared minus 2x plus 3 dx?
But
Yeah.
you have the
No.
x squared, so it's.
You
you're
can't just do the
doing
natural,
chain rule as well from the derivative.
because of the chain rule. Yeah.
Well, normally it would just be times 2x, so it would just be over 2x. Like.
Nah. Because of the chain rule, yeah.
2x minus, well,
You
I'm
could-
saying it would be, like, if you were to take the derivative of the natural log of that, it would be times, well, it
Can
would
you
be the natural log
separate?
of that times 2x minus 2, right?
Isn't it just 3 times 1 over all of that? So could you like multiply it out?
I don't even know what that means. This was the part that I think you guys are going to be even more annoyed with, yeah.
Triangle, long division.
There's one more thing we did, and you're
Arctangent.
Complete the square.
completing the square is what we need to do.
I don't know how to do it, I just remember that's what it was.
Are you guys with me that I could call this x squared minus 2x plus 1 plus 2? And how does x squared minus 2x plus 1 factor?
X minus 1, x minus 1.
So x minus 1, the quantity squared, plus 2. And if we're sitting in this position, this is an integral of a constant over a function squared plus a constant, right? Pretty darn much like the integral of arctan.
So let's just take the 3 out.
That's fine. I mean, instead of 1 over a, we're going to have 3 over a. That's all that's going to happen there.
Oh, yeah.
So 3 over the square root of 2 arctan of x minus 1 over the square root of 2 plus c. Let's not forget what we already had. See, that wasn't so bad, right?
Bruh.
Bruh.
I just never got to tables, but, so. It's okay. We'll get there maybe.
Integration by tables.
We're skipping integration by tables.
What's the area under the table?
Yeah, literally. Integration by tables. Oh, are we done?
Yes, I'm kind of thinking I should pre-teach or start the improper integrals so that you have more time during the block day to review, to finish homework and get ready for the quiz and ask questions. I feel like you guys would be better off being able to start more of the homework. But only if you guys are comfortable with that.
Sure.
Are we skipping?
Yes.
We're skipping the integration by tables.
When are we skipping just, also, sorry, is there an 8.6?
We did it in 8.6 was the trapezoid rule and the Simpsons rule that we did at the beginning or at the tail end of 1151.
Okay.
So there is an 8.6.
Will it, like, will we be tested on it?
Nope.
Should we review
All right. To start with, you guys, can I have you guys just everybody take an integral on top here? And you don't even have, like, you can throw them in your calculator. I don't care.
The second one is 0.99.
The first one's 0.9. Can I guess what the next one is? 0.8.
Something tells me the next one's 0.999.
It is. And the one after that, 0.9999.
And then the next one's
I don't know.
Everybody good?
The next one's 1.
Oh,
Yeah, well, it's not as cut and dry as we can just say it's equal to 1, yeah?
Like, you do a little squiggly thing and then it's 1. The limit.
Well, no, it's more that we need to understand how do we know it's 1. Okay? And so, because sometimes if we try to integrate to infinity, it will equal 1, and sometimes it'll equal another number. Sometimes it's going to equal infinity, right? And so, like, we need to kind of have a process for how do we do this when you can't plug infinity in? What do we do when we can't plug a number in? We take the limit. So, we want to say could be 1. But instead what we're going to do, because you can't plug this in, is we're going to think of the integral not as a value, but rather as a function. Okay? So this whole thing will be, what we're going to do is we're going to take the limit, typically we use b, as b approaches infinity of 1 to b of 1 over x squared dx. And all of a sudden, we're changing our integral into a limit as b approaches infinity, and this integral is now a function of b. Are you guys with me? So, you guys, how do I integrate 1 over x squared dx? What is it?
1/2 negative 1/2 x to square root x.
It's negative x to the negative.
Negative 1 over x. Negative x. Everybody good? And we're evaluating that from 1 to b. And we're taking the limit as b approaches infinity. Are you guys with me that negative 1 over x evaluated from 1 to b is negative 1 over b minus negative 1 over 1. And then we're going to take the limit as b approaches infinity of that value. Now, the limit of 1 over b, or negative 1 over b as b approaches infinity is 0. Minus negative 1 is plus 1. So because the limit equals 1, we can say that the integral from 1 to infinity equals 1. So this kind of helps us get around, using this limit approach, this helps us get around when we can't just plug in. We can take a limit to do the problem. So let's look at another example. All right, you guys, what is the integral? So we're going to take the limit, again, as b approaches infinity, because we can't plug infinity in. 0 to b, e to the negative 2x dx. What is the integral of e to the negative 2x dx? Thoughts?
1 half plus 1 half.
So, say that again.
It is just 0 plus 1 half. Well, because e to the 0 is 1.
So e to the infinity is 0.
It's negative.
E to the negative infinity. So think about the graph of e to the x.
Okay, yeah.
Cool? That seems like a good place to stop. We'll pick up with the rest of